Michael, welcome to the stage. How you doing?
I'm doing great.
All right, and lots of love from our audience. Check it out. So, have a seat.
Thank you.
And by the way, if you're walking by right now, just have a seat and join the conversation. So, we're going to keep this, once again, as open as possible. I'm going to ask a few questions, and then we'll see what it actually comes down to when we talk about sustainability design for semiconductors. So tell us a bit about what Siemens is doing in the digital twin, we could say realm, to connect design to manufacturing. Because as I understood it, these are two separate silos in a way.
Exactly. And whether you're a company that does both design and manufacturing, or you're a company that just does design and wants to hand it over to manufacturing, they very much have been treated as silos. Mm-hmm. So when you look at the main trends that's driving the semiconductor industry, right? You have advanced technology, new process nodes. This is a lot of technical jargon, right? But we always continue to push the technical boundaries as we move forward.
Okay.
The industry had to move towards having a very 100% accurate digital model of the semiconductor for design. Mm-hmm. It's the only way you could design it. It's the only way you could guarantee that it's going to work the way it's supposed to do in terms of production. But on the production side of things, companies have built foundries, and the way they build foundries is what's worked in the past, they keep doing it and continue to repeat that over and over again. But that's not going to work anymore because we need more and more foundries. And a lot of companies out there are becoming more global. They're building foundries all over the world, and they really need to be optimized.
Right.
So one of the newest areas that we're focusing in on is now the digital twin for the foundry side.
Okay.
And so now with that, you're able to start making some better decisions. If you wanted to build a foundry today, it would only cost you about 18 billion euro.
Wow.
So if you're going to invest that type of money, you want to be pretty sure it's going to work the way you designed it up front.
Right.
And you can't just assume that what you did in the past is going to continue to work in the future. So this is where the digital twin on the foundry side starts to come in. So you could start simulating that long before you ever lay the first brick.
Right.
And guarantee that that's going to work moving forward. So just having the two digital twins isn't enough, though. We have to link them together. Because we've already had this very solid, complete digital twin of the design. What if we could actually move that forward into the digital twin for the foundry for manufacturing?
Okay.
And now with that, we could actually start to simulate and optimize the foundry moving forward. So before we start producing any semiconductors, we know it's going to work right and be complete moving forward.
All right. Thank you for setting the scene.
Yep.
All right. Now you talked about that gap. How do you go about to actually bridge that gap? What's your plan to make that work?
Well, so it's a complicated problem, right? Because we just touched on a couple of different important points right here. But you have to worry about things like traceability. Mm-hmm. You have to worry about things like design for manufacturability. Mm-hmm. And one of the really important things right now is sustainability as well. Mm-hmm. And you have to weave all these different threads together. Mm-hmm. And the goal is to be able to do them in such a way that you can optimize every single one of them as we move forward. And specifically, it's the way that you weave those digital threads together is really all about the data that needs to be passed from design and into manufacturing. And the goal behind that is to be able to link and create a traceable model such that you could actually predict things moving forward and you can actually optimize things coming back. And that's the key to bringing this all together.
Mm-hmm, mm-hmm. Looking at this slide over here, I see that word resilient.
Yep.
Which is also, I guess, especially when we think about the supply chain.
Yes.
Like how do we make that more resilient in the semiconductor field?
And it's important. It was always an issue. I wouldn't say a problem until we went through COVID.
Right.
And what happened was, again, all these foundries where they needed their supplies for the supply chain, they would typically get them from a single source, mm-hmm. possibly have backups. Mm-hmm. But if it worked, they would continue driving it always from the same point. That failed miserably during COVID.
Right.
And the whole industry realized that they really needed a better way of tracking all this. And now it goes back, how do you make sure that you could second source the stuff, and how do you make sure that it's going to work moving forward, because it's not coming from the same place anymore. Plus, these foundries are in different locations. If you have a foundry over in Taiwan and you're building one in Arizona, things are very, very different. So really what it's about here is now it goes back to the digital twins and how we link all the digital twins together. So you have the digital twin of the product. You have the digital twin of the fab. You start using that data to move forward, and now you could start simulating what happens when I get my supplies from a different vendor. And is that going to work within the entire model? And that's how we start connecting all of this together. And then we start building this loop forward from design and be able to actually guarantee that we're going to have the resiliency within the supply chain moving forward. And the other thing I want to touch on here is it has to be secure at the same time.
Right.
Because there's a lot of chance for bad actors to get into the supply chain.
Unfortunately, there are always bad actors.
Absolutely.
Right.
And it's from design all the way through manufacturing. So it has to work, it has to be secure, and it has to be trusted throughout the whole process.
So was that one of the most stressful times in your life during COVID? Thinking about that supply chain? I mean, your position?
Absolutely, right? And you know, my customers, right, were not only suffering because they couldn't get the people in there to work, they couldn't get what they needed. The consumers were demanding the products. The consumers couldn't get the products. I had to buy a new car during COVID.
Right.
I had to buy a car with half the features probably I could have had.
Right.
Because the car manufacturers couldn't get the semiconductors they needed, because the semiconductors couldn't be built because they couldn't get the supplies.
Right.
So it was hierarchical stress.
Kind of like impacted by by the own industry, right?
Exactly.
In a way.
Exactly.
So did this accelerate the how should we say the progress you made in a way?
Yeah, and so, you know, many things came out of this, right?
Right.
Number one, we realized that we needed more manufacturing capability, which led to the idea of globalization. Yes, we have new problems like we talked about already with that, but that definitely came forward and we started to solve those problems. The second sourcing and third sourcing of the elements that we need to do design and manufacturing, those are all being handled now. So we're in a much better place we are now, even though we have more problems to worry about than we had to in the past.
Right. Got it. So let's talk about the industry in general, maybe. Yeah. How do companies deal with the slowdown in Moore's Law?
Absolutely.
Tell us a bit about Moore's Law. Nobody's heard of it before.
So Gordon Moore was the founder of Intel. And early on in the early days of Intel in the 1960s, he realized that semiconductor devices every 2 years were doubling the number of transistors and doubling the compute power of the semiconductor devices. And the industry said, we'll call it Moore's Law. And it was true all the way through the 70s, 80s, 90s, 2000s. But we're having problems now because semiconductor devices are getting smaller. And we can't continue to make transistors smaller. So there's a couple of ways to solve the problem. You build bigger chips. Well, bigger chips cost a lot more money. And we talk about yield. So when you build a wafer, not all the chips work on it the first time. You may have to throw away some of them. But with the larger chips, you have to throw away more of them. So it's not cost effective either to do larger chips. So that's led to newer technologies and something that we call 3D IC.
Okay, what is that?
And so what 3D IC is a way to take existing chips and existing process technologies, ones that we could manufacture very easily and quickly together, and put them together on a single package. So instead of having one chip in one package, we now have multiple chips in a package.
Okay.
And there are many benefits to that. If you need a super fast processor using the latest technology, you could do that. But if you have other pieces of the design that don't need to be super fast, you could use other older technologies and reuse designs from the past and put them into the package. So you're now basically assembling different pieces of the design. We call them chiplets, integrating them all in a common package. And you have the benefit of it being cheaper because you're using, in some cases, older technology. You have benefit sometimes of it being less power. And this now goes back to sustainability because we don't want to use up more electricity than we need to in designs. because we don't have to worry about having inefficient parts of the design that we would get in larger chips by being able to bundle things much closer together in these small chips. And it allows us to reuse chips in multiple packages. And this now goes back to sustainability because we're not always pushing the envelope, trying to develop new things, bring up new processes along the way. So there's many added benefits to just being able to put this all in there because we're seeing benefits from a cost point of view, from a sustainability point of view, from a performance point of view, and it's really going to be the future of the industry moving forward.
So in a way, the slowdown has, once again, a positive effect.
Exactly, yeah. Absolutely. And, it's like innovation comes from having these challenges that we have to deal with.
Right.
And it was one of those things that was always out there. The idea was always out there, but the need presented itself, so we had to bring it into today to make it happen.
Interesting. So how is Siemens helping customers exactly with 3D IC design and also verification?
Absolutely. So it goes back to when we were talking about linking all of this data together. And the way we link this data both forward and back is through something that we call digital threads. And we have multiple digital threads that are part of the solution. The first one we call semiconductor lifecycle management. And you can think of this as the main data model that we put all the data into. Then we have threads to handle the beginning of design. We call it system-defined system engineering. We have digital threads for IC design and manufacturing, into the 3D IC that we were talking about, all the way into manufacturing and the equipment. So what's unique about our solution is that Siemens is the only company that could bring all together all the different domains needed to do 3D IC. Because it's not just a semiconductor problem. It's not just an electronics problem. It's not just a mechanical problem. It's a multi-domain problem where all these need to come together. We have the data model. We have the tools. We have the solutions. And we have the flows that allow us to bring them all together and actually help our customers do this in an optimized, efficient way.
Sounds good, doesn't it? Looking at the audience now, look at that.
Yes.
Full rows here.
Absolutely.
Looking at the next slide. Speaking of a flow chart, maybe we can go to the next one. So explain this to us.
So it's really tying all these threads together now, right? So our goal is sustainable semiconductor design in the process, right? So we need a data model. We need a way to link that data together. We need virtual models of both production and design to be able to simulate everything early and optimize everything early moving forward. And it all comes together. And what we enable our customers to be able to do is actually produce those sustainable semiconductor devices moving forward.
So we can approach you, I suppose, directly after the talk?
Absolutely. We're right over here.
We're right over there?
Closest one to the stage.
There we go.
We have plenty of people from design all the way through manufacturing that could talk about each one of these steps and details, from the production, from the design, virtual models, digital threads. We have everybody here that you need to talk to.
So once again, I think at least half of the people sitting here, I think, just joined after, I don't know, we were already halfway through. So once again, if you do have any questions about what we're talking about here in general, semiconductor design for sustainability, and how we are linking design to manufacturing for a more sustainable semiconductor future. That's basically what it was all about. Michael is the man to go to. Let's give him a big round of applause. Michael, thank you very much for joining us. Our time here is up, unfortunately.
That's
but
all
that's
right.
how it is.
Thank you.
All right. Thank you, man.
Take care.
Take care.